In this video, we are going to work out some different things that we can do with our basic future value, present value formula that we didn't do earlier. Now we had this basic formula, right, that told us this relationship between a present value and a future value. And this is an equation. And what that means is, if you give me 3 of the 4 variables in this equation, I can solve for the 4th one. And right now, that's how this is arranged to solve for the present value. If you give me future value, time until future value, and the rate of change, or the rate of interest or the rate of return, I can calculate the 4th variable present value from the other 3, because there are only 4 things in this equation: present values, future values, time until the future value, and R. And then we also can rearrange this for solving for the future value, and that is the future value is equal to the present value times 1 plus R to the T. And those were the 2 that we've already looked at. Now, there are 2 other variables, R and T. And so in this video, we're going to look at how you could use this equation and use algebra to solve for R and T. Now, let me stop and say that this is going to be a little more advanced algebra than you're normally going to see. You will rarely, if ever, actually do this math by hand. You're going to probably have a financial calculator, or you're going to have Excel. But you do need to see and understand that behind those calculations that you don't see in Excel or in your financial calculator, there is actual math that does this, and you could do it by hand even if you don't. All right, so we're going to start with this format and this arrangement of the formula, and we are going to solve for R. All right, now the way we are going to do this step by step, right, because we need to isolate R and get everything else on the other side so that we can show the algebraic solution here. So I need to get this present value on the other side, then I need to get the T on the other side, and then I need to get the 1 on the other side. Now, the first step's easy. I can move the present value over by simply dividing both sides by the present value at time 0. And that leaves me with this expression, and now I've got to handle getting the T over to the other side. Now, there's a couple different ways that you could do this. All right, you could do some natural logs, and that would handle this. Now, the other way to do this is note that this is an exponent, and one way to get rid of an exponent is to take a root. And so we can take a root of both sides to get rid of the T, and the root that we would need to take is the T root, right? And so we could take this teeth root, which is a dumb way to say it, but that's what you'd say, of both sides. And that would leave us with this. And now the only step we need to take is get the 1 over to the other side. And so, well, you would have and there you go, right? You get this expression is equivalent to R. All right, and that's how you would solve for R. Now, if I want to solve for T, that's where it can be a little more cumbersome. So let's clear the board and we'll start working on how can I isolate a time factor. Before I move on, let me say, what is this useful for? Well, if you know how much money you want to have at a specific time in the future, and you know how much money you can set aside right now, and you know how long until that future time is, you can figure out what rate of return do I need to earn on that account so that I can put away this present value right now, and at this time remove this much out of that investment. And so this can be very handy. Another thing to think about is, again, that's an investing standpoint. On a borrowing standpoint, you can think about, how much money you're going to have to pay back at a point in the future. You can think about how much you're borrowing right now and how long until the maturity on that loan, and you can figure out what's my interest rate on this loan. And so this is handy for solving for the rate when you know the values at two different points in time and how far apart in time those two values are. All right, so in order to get to this time t, we have to do the same thing, right? We need to get everything else onto the other side and isolate that variable in this equation. The first step, same thing, right? I need to divide both sides of this equation by the present value at time 0, and that gives me this. And now we get into something that we don't do very often in our day-to-day math, which is how do I get an exponent out of here and get it kind of down into the equation so that I can use it. Here we're going to use something called a natural log, or taking a logarithm of both sides. And now the properties of logarithms, right, there's a math rule that says if you take, and this is ln, if you take a log of an expression where you have some number raised to a power, this is equivalent to that power times the log of that number. Okay, and so this means that if we take a log of this term, 1 plus r acts as the x and the t acts as the y, and we are going to get t times the log of 1 plus r. What that's going to look like is I'm going to have to take a log of both sides, because this equation means if I do it to this side, I have to do it to this side, or else it's no longer equal, and that means it's not an equation, and that blows up the math. All right, so I'm going to take a log of future value divided by the present value, and that is going to be equal to t times the log of 1 plus r. All right, now I can use this a little easier because, well, now I know how to get to isolating that t on that side. I'm going to divide both sides by the log of 1 plus r. And so you end up with the log FVT divided by the present value now, divided by the log of 1 plus r is equal to time t. All right, now what is this useful for? Well, again, this is figuring out a length of time. If you know what current interest rates are in the market, you know how much money you want to put aside, you know how much money you want to get back from your investment. One question you might ask yourself is, how long do I need to invest this amount of money at this interest rate so that I will be able to withdraw this future value? So like, I got $500, interest rates are 5%. How long until I can get, $550 back out of my account? How long will it take me to earn that return? Okay, well, this equation will show you how to do that. All right, now we're going to then take these equations and we are going to use them to figure out some specific small little examples. All right, so we've got our equations set up here. Let's take this first equation here and see if we can solve for an r that makes sense, right? So let's say that you want to save up some money, but you need the money back in, 2 years. Okay, so we are going to set aside, let's say, $100, and we've got 2 years to invest, and we are hoping that we can get back $130 within 2 years in our investment. Okay, well, what rate of return would we need to get on our money if we're going to get, this $130 back in 2 years' time, right? That's the kind of problem we might have. Well, we would plug in our information into this equation, right? So we've got 2 years, so t is 2. We want to get back $130 in the future with a $100 investment today. Subtract out the 1. What is the rate of return that we need on this account in order for that to be possible? Well, let's do that math. All right, so we're going to take 130 divided by 100. All right, well that's 1.3. Now we're going to take a square root. Now I could just hit the square root button. I'm going to show you something right here that instead of taking a square root, we're going to raise it to an exponent because not everything is going to have a 2. And if you just take a square root, the reason it's called a square root is because, well, that's the square key, right, with the 2, and this is square root. The way roots work is if you take, x and you have a y root, that is equivalent to x to the 1 over y power. And so instead of taking a square root, which you can see is 1.1402, you could also take 130 divided by 100 and raise it to, I'm going to open a parentheses, 1/2, close that parentheses, so that's 0.5. So I'm going to take it to the 1/2 power and I get the same thing. All right, now I'm going to take out the 1, and there it says 0.1402, and this is 14.02%. All right, now let's check that. Right, we know the basic relationship says if you take 1 plus r, all right, and you raise it to the t power, so raise it and then multiply it by our present value, that's how you get to a future value. And yeah, it's a little off because this has some rounding in it, but yeah, it looks like this was the correct way to get an equation to show me r. Okay, so we've done the solution for a little example doing this. Now let's do one trying to solve for t. Okay, this is going to be, again, using logs, so that's a little different. Once again, I need to know 3 pieces of information to solve for this fourth one. So I need to know a future value. I need to know a present value. I need to know what my rate of return is, and then I can tell you how long it's going to take for this present value to turn into this future value at this rate of return or rate of interest. Okay, so again, one thing we might want to know, well, if I put some money back at 10% interest, how long until that money doubles? Okay, so that would be an interesting question. So let's again base it on $100. Okay, so if you want to know how long it's going to take for $100 to double, that means to turn into $200 at 10%. This is the equation we can use. So we're going to take the natural log of the future value, 200, divided by the present value of 100, divided by the log of 1 plus 10% rate of return, so 1.1. That is going to tell us how long it will take until that happens. Okay, so the first thing I'm going to do is I'm going to take the 200 divided by 100. All right, now I need to take a log of that. Right there is the ln, so I'm going to say log. Then I'm going to divide by, open up a parentheses, 1.1, take a log, close the parentheses. It says 7.2725 years. Okay, now, does that work? Well, okay, well, let's find out. Now we know present value times 1 plus r to the t is equal to the future value at time t. All right, well, the present value was 100, 1.1, right? 1 plus 10%. 7.2725 equals, all right, well, let's check this. All right, so 1.1 raised to 7.2725 power times 100. Again, a little bit of rounding, but yeah, 200. And again, the rounding is, we didn't write down enough decimal places. This is actually true. This has got a little bit of error in it. Okay, and that's how you do this. Now again, I do not expect that many of you will ever do this by hand, but in future financial lessons, you may see stuff like this popping up and some of the intuition popping up for figuring out some different things like equivalent annualized rates and annuity factors and some other things like that. And so, like I said, you may see some of this stuff pop up later, but again, you will rarely ever do it by hand.